Fibonacci numbers with integral calculus. Fibonacci series with integral calculus. This is the mind-blowing discussion that we are proceeding upon. Fibonacci series with integral calculus. People would have heard about the single dimension series, but this is what we are talking about, dual variable series. People would not have heard about dual variable series. Is there any series available that is dual variable, dual independent variable? What a series is? If I take Fibonacci series only, then Fibonacci series is 1, 1, 2, 3, 5, 8, 13, 20, 21, 34, 55, 89, and so on. In any series, there are two things as we have mentioned repeated. In any series, there are two things. One thing is the position in the series, and one is value at the position. Position number 1, Fibonacci number is 1. Position number 2, Fibonacci number is 1. Position number 3, Fibonacci number is 2. Position number 4, Fibonacci number is 3. Position number 5, Fibonacci number is 5. Position number 6, Fibonacci number is 8, and so on. Position number and value that can be represented as x-axis and y-axis. These are our explanations. This is typically not available in any of the book because we are talking about molding any summation series into calculus. This is the concept that we are pursuing. Can I convert any summation series problem into calculus? There can be innumerable problems in the world that can be converted into calculus. And calculus has only one protocol. That is, it operates on continuous function. If someone has a continuous function and it does the integration, calculus works in integration and differentiation. If there is a continuous function and someone is calculating integral calculus, someone is going with integral calculus, then it will do area calculation of the continuous function. If this is x-axis and there is a function like this, then it will do the area calculation of the function with the x-axis. There is more into it called differentiation. If there is a x-axis and there is a curve, then it will calculate at any point what is the y by x. Understand? I believe these two concepts should be very clear. If this is a some curve, this is x-axis and this is function over x. There is some curve here. If I calculate fx dx between x1 to x2, it will give area underneath it. Understand? That is called integral calculus. If there is a curve like this, and if I do differentiation of this curve at any point x, then it will go up. This is the x. What is dy by dx of this x? At this point, what is y by x? That is differentiation. Y by x means not this y by this x. If this is x-axis, then at this point it is x and this is y. At this point, dy by dx or differentiation is not this y by this x. Okay, that's why I brought it. At this point, if I take a this line is a straight line. Okay, it does not look like a straight line, but every point it is a straight line. But that straight line is changing at every point. Understand? I believe it is understandable. Every point has a straight line. This point has a straight line. This point has a straight line. But this straight line is different for different points. At any particular point, if I want to get the dy by dx, at this point, what is the straight line? Someone would say, are you talking about the tangent at that line? Yeah, same thing. Tangent at that line. If I draw a tangent at this point, then that tangent, consider, this is the minute thing that no one knows. And then he starts jumping here and there. At this point, what is dy by dx? At this point, what is the direction of this line? That is a straight line at this particular point. That is tangent at this point. If this is a tangent, then take it, remember it, and now bring the tangent exactly parallel. Okay, exactly parallel. I can move exactly parallel. keeping the slant angle with the x-axis same, and then bring it to origin. This point should touch the origin. Understandable? Now draw any x and any y. Any x, then this will be y. What is this y by x? This is dy by dx. Understand? Okay, dy by dx is not that at any point what is dy by dx means this y by this x. This is dy, this is not dy by dx. Dy by dx is at this point what is the direction of the, if a liquid is flowing zigzag manner somewhere at any point, what is dy by dx? At that point, exactly at that point, what is the direction of the liquid in a straight line? That is tangent at that point. That direction, if there is a delta x, then what is delta y in change? Delta y by delta x dy by dx. Or whatever direction I get, draw a straight line, bring it to origin, and then say x and y. What is y by x? Or people generally say, take an infinitesimal. That's why I don't like this delta x and delta y. Infinitesimal small delta. That's why I could never understand calculus while I was reading calculus when I was in a school time or what. Take a delta x, consider it is tends to 0, and then there will be delta y tends to 0. Then both are tends to 0, then what are you doing? It is 0. If delta y by delta x tends to 0, then it is 0. What is meaning of this calculus and all? Whatever is being taught, I am 100% sure that 100% of students, they do not understand anything. Okay, they mug up and they go to examination, they crack the examination. But in reality, if you don't understand in reality, then how you will convert your real domain problem into calculus? Because calculus solves a problem very quickly. That is true. But how to convert a real domain problem into calculus if you don't understand the meaning of calculus? Dy by dx, if this is x-axis and this is a curve, at this point what is dy? Every point dy by dx will be different. At this point what is dy by dx? Y by x? No. At this point, if consider this is a pipe and through which liquid is flowing, at this point, what is the direction of the liquid? Everywhere liquid is changing its direction. See, liquid is changing it. At this point, what is the direction of the liquid? Are you talking about a straight line direction? Yeah. Every moment, liquid is flowing in a straight line only. And that straight line is changing everywhere. Okay, at that moment, what is the straight line? Just capture it. If I am talking about this point. This is a tangent line or a straight line. Just remove it. And then take it parallel, and bring it to origin. Now, this will affix at the origin. Now this is the line. Now take any x, then see what is the y. That y by x is dy by dx as that point. This is dy by dx. If someone understand it, then he can mold any problem into differential calculus or differentiation. Or what is y by x? If I take this as a curve, and this curve equation is fx dx from x equal to 1 to x equal to 2 is the area in between. Dfx by dx, that is differentiation, dfx by dx at any point x equal to x1, integration from point x1 to x2, that is the area. Differentiation at any point x1, differentiation at any point x1 is nothing but at point x1 or x1 and y1, what is the tangent at that point? If I know the tangent, for this tangent, what is y by x? That is, okay, if someone understands this minute concept, it will be very easy for him to convert any problem into calculus. Anyway, we are converting our Fibonacci series summation into calculus, and we are talking about dual dimension Fibonacci series, where x and y are, where we have x and y. What are you talking? Fibonacci series at any position x, consider it is function over x. That is the value. There are two things. One is x-axis, that is the position number in Fibonacci series. One is function over x-axis or y-axis. That is the value at that position. If I am talking about position number 5, then fx is 5. Position number 7, then fx is 13. Make sense? Now I can represent fx function over x or Fibonacci number at position x as function over x as same as ux. Another representation. U and bottom right x, ux as x as subscript, or fx function over f in bracket x bracket close function over x, fx or ux. Now I have a Fibonacci series as u1, u2, u3, u4, ux. The number, the value at position number x, u1 position number 1, u2 position number 2, u2 position number 2, what is the value? That is u2. Understandable? Now in that manner, now what is your two dimension, two variable Fibonacci series? Two variable Fibonacci series is represented as P and bottom right x comma y. Ux at position number x, what is the Fibonacci number? Ux. I know Ux. What about Px comma y? P and then bottom right x comma y, where x and y are in two dimensions. Okay, so as I have mentioned, if this is xy plane, then this is x-axis, this is y-axis, this is origin. If I take any point here x comma y, then pxy is a vertical at this point, also called z-axis. pxy, pxy, pxy is a hybrid, a two-dimensional Fibonacci series that is written by me, means by anyone. What is this pxy formula? That is uy into uy plus x. It can be anything else also. Yeah, it can be anything else. This is what function I have taken. P x comma y equal to u y into u y, then whole into u y plus x. Okay, this is pxy. Means if I have any point here x comma y where this is origin, then the vertical here is uy into uy plus x. This is the function. But here independent variable are two, x and y. Okay, uy is a Fibonacci number at position number y. uy plus x is a Fibonacci number at position number y plus x. Multiple of these two then makes a hybrid Fibonacci series pxy. What is summation of pxy? That is the question that is arising. Summation x equal to 1 to m, summation y equal to 1 to n, px comma y. This is the question that is asked. Means I have m comma n points are there on xy plane. If I have pxy against each point, this is the first point, p11, p12, p13, like so. P45, P4 comma 5 is U5 into U5 plus 4 or U9. So if I add all m into n pxy, then what is the result? That is again the question mark. Now to solve it, we are using integral calculus. Integral calculus works in a continuous function only. Consider this is pxy, which is discrete in nature because it is only vertical. There is a surface here called gxy. It is a plane surface. Many times I have demonstrated it. Consider this is a gxy. gxy is a plane surface. Just consider the front part, not the back part. Consider the front part. This is pxy. Sorry, gxy. gxy is a continuous function. Or this is gxy. gxy is a continuous function. This is pure continuous function. Means if I take any x comma y as fraction also, it will go up and hit the gxy. Whereas pxy is only at x and y, those are whole in number. If I take any point 1.5 and 2.5, x equal to 1.5 and y equal to 2.5, this is not going to touch any pxy because pxy is only available at x equal to whole number 1, 2, 3 for integer in computer term and y equal to integer. If x and y are in float number, fraction, then it is not going to touch pxy. But gxy, which is a continuous surface, it will hit the surface. And integration works on continuous surface, continuous line, not on the spike line, vertical line. They do not work in that fashion. If that is the case, then how I can compute addition of pxy? Summation x equal to 1 to n sigma summation y equal to 1 to n pxy. Means I have a matrix of numbers. First is x is 1, means p1 1, p1 2, p1 3, p1 1, p1 n, p2 1, p2 p2 2, p2 3, p2 n. Last will be pm1, pm2, pm comma n. This is what is the our full two-dimensional Fibonacci series. I have to add it. Okay, in order to add means p, what is pxy? Uy into uy plus x, where uy is the Fibonacci value at position number y in the Fibonacci series. Understandable? Okay, then how we can compute this? To compute this, what we do is we take any x comma y and see what is the next x comma y. If this is x comma y, we call it sampling. Sampling of a surface. If I have a surface, imaginary surface, I have done sampling at some point, that is pxy. Means pxy is defined at x comma y. The next point on the surface where pxi will be defined will be x plus 1, y plus 1, y plus 1, x plus 1, xy. Okay, so xy, x plus 1 comma y, x comma y plus 1. So these are the nearest point on which the next pxi is defined. Means I have a rectangular region. If I have a x comma y where pxy is there, then it has a rectangular region under which there is nothing, empty. That is x plus 1 comma y, x comma y plus 1, x plus 1 comma y plus 1. That is a rectangular region. Inside there is nothing. The next pxi along x direction is at x plus 1 comma y. Next pxy at y direction is x comma y plus 1. In corner direction it is x plus 1 comma y plus 1. Okay, now if I take a rectangular region between x, consider this is the x comma y, this is x comma y, and I am keeping this x comma y. So this point is x comma y, this point is x comma y, this is origin, this point is x comma y, this point is x plus 1 comma y, this point is x comma y plus 1, and this point top right corner is x plus 1 y plus 1. This is a rectangle inside which there is nothing in pxy. Now it will go up this rectangle and it will hit the gxy. If I say gxy dx dy from x to x plus 1, y to y plus 1, it will give the volume under the gxy with this edge on xy plane as intersection. Means I am trying to say if I match both things, if I match this volume with pxy, at left bottom corner is a point called x comma y on xy plane, and there we have pxy. If pxy is same as the gxy, that is a flat surface, gxy dx dy, volume with xy plane, x equal to x plus 1, y equal to y plus 1, then we can compute the volume under gxy. Can this volume will be same as pxy? Why you are doing like so? I'm trying to convert discrete function pxy into continuous function gxy. This is what I'm trying to do. If I'm succeeding in getting gxy in that manner, consider I'm succeeding in getting gxy in that manner, then I have m into n pxy, m into n pxy, where the last pxy is at x equal to m and y equal to n. For that the volume will be right hand side n m to m plus 1, n to n plus 1. So m to m plus 1, n to n plus 1, gxy dx dy. That will be the last one. For each pxy, I have a volume with gxy and they are matching with each other. In that manner, if I want to do summation of all the pxy, that is same as summation of all the sub volumes. And summation of all the sub volumes, where all sub volumes are contiguous to each other and non-overlapping will be integration from lower end to higher end, and then we are done with the summation. This is how someone can mold his problem into integral calculus. This is priceless discussion. If someone has problem in physics, someone has problem in chemistry, and problem is something different, nothing to do with calculus arena, but how he can convert his problem into a calculus domain problem, and then he can do the calculus computation and convert it back to his domain. It is as good as if I am speaking, my voice cannot go to 5,000 kilometer away, but a very high speed electromagnetic signal can go 5,000 kilometers. Very high speed means high frequency. Now I can modulate my voice on the high frequency electromagnetic wave, and then it will reach the 5,000 kilometer, and then I can demodulate it, and then anyone can hear on the speaker. This is what technology is. Similarly, if someone has problem, he can modulate his problem on the calculus, get it solved, and demodulate it and bring it to your domain. These discussions are not available in any of the books. Anyone can try. This we are trying especially for the discrete to continuous. Now, if I'm trying to calculate pxy summation x equal to 1 to m, y equal to 1 to n, then that summation will be x equal to 1 to m plus 1, y equal to 1 to n plus 1, gxy dx dy. If I know gxy, to know gxy, we take any x comma y pxy, that is uy into uy plus x. That should be exactly equal to limit x to x plus 1, y to y plus 1, dxy dx dy. In that manner, I have to find a gxy for which if I do dual integration and set limit x to x plus 1, y to y plus 1, then it should come exactly as uy into uy plus x. What is uy and what is uy plus x? That is under question mark. Under Fibonacci series, ux equal to ux minus 1 plus ux minus 2, or ux equal to 1 plus the square root of 5 by 2 to the power x minus 1 minus the square root of 5 by 2 to the power x by a square root of 5. We will use the last one because we need a function in Fibonacci series value in terms of its independent variable x. Okay, in that manner, what will be pxy if it is uy into uy plus x? Consider now, the problem with Fibonacci series is the last number 1 minus the square root of 5 by 2 is negative. To the power x, if x is even, then it is positive. If x is odd, it is negative. Now consider that I have a equation, Fibonacci series. We are changing the formula now for easiness. Now Fibonacci series fx or ux equal to 1 plus the square root of 5 by 2 to the power x plus a square root of 5 minus 1 by 2 to the power x. Now both are positive, and it doesn't matter. If it is positive to the power x will always be positive by a square root of 5. Consider this is a Fibonacci series. 1 plus a square root of 5 plus 1 by 2 whole to the power x plus a square root of 5 minus 1 by 2 to the power x by a square root of 5. This is the Fibonacci series. Then y equal to a to the power y plus b to the power. I say a as a square root of 5 plus 1 by 2 and b as a square root of 5 minus 1 by 2. So fx or ux equal to a to the power x plus b to the power x by a square root of 5. In that manner, now I have Fibonacci series pxy is uy into uy plus x, and that will be resolved as a to the power y plus b to the power y by a square root of 5 into a to the power y plus x plus b to the power y plus x by a square root of 5. Okay, by a square root of 5 by a square root of 5 will become 5, that we will discard right now, and net equation will come as a to the power 2y plus x plus b to the power 2y plus x plus a to the power x plus b to the power x, where a into b to the power anything is 1, because a into b is 1. Someone can try. Net pxy will come as a to the power 2y plus x plus b to the power 2y plus x plus a to the power x plus b to the power x. If this is pxy, then I have to find gxy dx dy, x to x plus 1, y to y plus 1. That will bring this result only, and we have found it. What we have found it, if I take gxy as log a into 2 log a by a minus 1 in bracket a square minus 1 in bracket a to the power 2y plus x plus log b into 2 log b by b minus 1 in bracket b square minus 1 in bracket into b to the power 2y plus x into log a by a minus 1 log a by a minus 1 a to the power x plus log b by b minus 1 b to the power x. Please watch our previous videos, one or two videos, how we derive it. This is called successive approximation in calculus. Pxy equal to gxy dx dy. Gxy equal to d2 pxy by dx dy. Double differentiation of pxy with x and y. Okay, if someone does it, pxy is a to the power 2y plus x plus b to the power 2y plus x plus a to the power x plus b to the power x. Okay, if he does so, first if he differentiate with x, then it will come as log a to the power 2y plus x plus log b to the power 2y plus x plus log a to the power x plus log b to the power x. Understandable? If he does differentiation again with y, then it will be log a 2 log a, log b 2 log b. Understandable? Next will become 0 because a to the power x differentiation, this is the dual derivative. Dual derivative means dual variable integration and differentiation. If we do integration with x-axis, then we have to keep y constant. If I do differentiation with x-axis, then I have to keep y constant. Whatever I said gxy, that is the last gxy. If someone is doing integration from x to x plus 1, y to y plus 1, it will give the result. Okay, then once I get the dxy that we have got, then for final summation to get the final number, we will do integration x equal to 1 to m plus 1, y equal to 1 to n plus 1, gxy dx dy, where gxy is log a 2 log a by a minus 1 a square minus 1 a to the power 2y plus x plus log b 2 log b by b minus 1 b square minus 1 b to the power 2y plus x plus log a by a minus 1 a to the power x plus log b by b minus 1 b to the power x. If I this integration with dx dy x to f 1 to m plus 1 y to 1 plus m y equal to 1 to n plus 1, then it will calculate the net summation. So answer is in front of it. Okay. Now in Fibonacci series, what the problem is? Ux equal to a to the power x, b to the power x is different if x is even or odd. We have also discussed this. In that manner, ux when x is odd, it is a to the power x plus b to the power x by square root of 5. If x is even, a to the power x minus b to the power x by square root of 5. Make sense? Where b is the square root of 5 minus 1 by 2, a is the square root of 5 plus 1 by 2. This is Fibonacci number. If I do so, then I have pxy as uy into uy plus x. If I expand it, then it will ask you y is even or odd. If y is odd, then it will be a to the power y plus b to the power y by a square root of 5. If y is even, then it is a to the power y plus b to the power y by a sorry. If y is odd, then plus. If y is even, then minus. Same is uy plus x. What is your y plus x? If it is odd, then a to the power y plus x plus b to the power y plus x by square root of 5. If it is even, then minus. Tell me what it is. In that manner, what we do is we keep x constant. Consider x is odd number. Then we try for y odd, y even. Then 2 gxy will come. Because gxy will change if pxy will change. Pxy equal to limit x to x plus 1, y to y plus 1, gxy dx dy. I have to find dxy in this manner. If pxy is changing, dxy will change. How many times pxy is changing? First we keep x constant, then y will go odd to even. Then we will flip x, then again y will go odd to even. This is 4 combination. Now end is m comma n. If m and n again they will vary from odd and even in 4 times. 4 into 4, 16 gxy we will get to calculate the Fibonacci series. We will proceed from here. How to do so? Now, in order to do so, what is the solution? What we are thinking? Let's go with the actual pxy. Okay, what is pxy? Pxy, if I try to calculate, x is variable, y is variable. Let's make one variable and one constant. Let's say pm comma y. Pm comma y summation y equal to 1 to y equal to 1 to n p m comma y. M is constant, y is variable. Okay, if y is variable, then summation is pm comma 1, pm comma 2 up to pm comma 3 up to pm comma x, pm comma n. So pm comma x, sorry, pm comma y we have taken variable, pm comma y, pm comma n. Pm comma y is uy into uy plus m, where m is constant. Understandable? What is this solution? What this solution is? We have already done very extensively this. This solution, this solution where m is constant and n is variable, it depends upon n. N is odd or even. Okay, if n is odd, then if n is odd, the net summation comes as un plus 1 into un plus m. Okay, that much only you tell me. Yeah, un plus 1 into un plus m is the solution of sigma summation y equal to 1 to n p m comma n m comma y, where n is odd number. For even we will talk. So now we are trying to calculate, now we are trying to consider I have got gxy. Consider I have got gxy. What is the net computation of the solution? Net computation is limit x equal to 1 to m plus 1, y equal to 1 to n plus 1. Understandable? And then gxy dx dy. Let's compute the inside module first, outside. There are two layers. First layer is y equal to 1 to n plus 1 gxy dy. Whatever result comes, then that result we will integrate again with dx, x equal to 1 to m plus 1. What is the internal result? What is the internal result? Internal is limit n y equal to 1 to n plus 1 gxy dx dxy dy, where x is constant. That is the main. Okay, if I take into consideration of the initial problem, leave this problem, go to single dimension. Now we single dimension means m is constant. Pm comma y, where y is variable, means P1m, P1, Pm1, Pm2, Pm3 and so on. Pm1 is u1 into u1 plus m. What is the summation? Sigma y equal to 1 to y equal to n, where n is odd. Pm comma y. This summation, if I say, then it is something like Pm comma y. If I take any y, then Pm comma y should be same as Gm comma y dy from y to y plus 1. I have to find Gm comma y as a continuous function equivalent to it. Understandable? If I get Gm comma y, then to have the final computation, I will do limit y equal to 1 to n plus 1 gm comma y dy. That will be the final summation of this. First get gm comma y, that is a continuous function where m is constant and y is variable. Once you get gm comma y, then to compute the final summation, sigma y equal to 1 to n pm comma y, where n is odd number. To get the final computation, we will do integration x y equal to 1 to n plus 1 gm comma y as a function dy. And this result comes as u n plus 1 into u m plus n or n plus m if n is odd. Now in our calculation, we are calculating summation x equal to 1 to m, y equal to 1 to n, pxy, that is same as limit x equal to 1 to m plus 1, y equal to 1 to n plus 1, dxy dy, and then outer layer dx. Internal layer, if I see y equal to 1 to n plus 1, same thing what we did, gxy dy, instead of x there it was m. So the solution will come as n plus 1 into un plus x. Understand? This is how we proceed in Fibonacci series case. So now we have now our solution turned into x equal to 1 to x equal to m plus 1 un plus 1 into un plus x dx. What is the solution for this number? Understandable? Now let's proceed again to the single dimensional problem. Now we have solved summation y equal to 1 to m, 1 to n, p m comma y, where m is constant. Consider m is variable and n is constant. What do you want? I am saying x equal to 1 to m, p x comma n. The right hand side is constant, first is variable. Okay, in that manner, it will become un into un plus x. The term is px comma n will become un into un plus x, x term. If I x term, then again I have to find x equal to x plus 1, gx comma n dx. Gx comma n as a continuous function I have to find. If I find it, the net summation will be x equal to 1 to m plus 1 gx comma n dx. Okay, what is the, okay, in order to find the gx comma n, what is pxn? Pxn is un into un plus x. Understandable? Px comma n is un into un plus x. Understandable? Now, if this is pxn, then I calculate gxn. For that, I calculate gxn. Now, let's focus here. Un into un plus x is the x term, where un is constant. I can keep un outside. And now if I try to find continuous function gxn, that will be completely dependent upon the next multiplication factor, that is un plus x, because this is the only variable. Un I can just keep outside, not required right now. Means everything in converting discrete to continuous will depend upon the second factor in the multiplication of pxn, x plus n. Now let's see, now come to dual derivative. What we have achieved till now? We have achieved the final summation is coming as limit x equal to 1 to m plus 1 un plus 1 into un plus x dx. Understandable? Un plus 1 is constant, then I can kick it outside. Inside is un plus x dx. They're also same thing. Un I kept outside, un plus 1 means both are same problem. Both integration is same, only what I kicked out was un, and here what I kicked out is un plus 1. That's it. So whatever result comes, wherever un is there, I'll replace by un plus 1. Okay, thank you very much. Tell me the solution. The solution for the single dimension x equal to 1 to m px comma n, or un into un plus x. If I keep un outside, then the net solution for this summation, if I take integration m x equal to 1 to m plus 1 gx and dx, the actual, we have talked a lot about it. Independent of m, m is odd or even. Even if it is odd or even, doesn't matter. The solution that is coming as a un, that is I have kept outside, this will be again outside only. Un outside, and in bracket un plus 1, in bracket um plus 2 minus 1, plus un in bracket um plus 1 minus 1, bracket close. There are two terms in the solution. So one is un, that is outside, and inside it is un plus, or if I solve it completely, it will become un plus m plus 2 minus un plus 2. This is the factor that is related to un plus x, where un is outside. Now, if I solve it for two dimension, un plus 1 I have kept outside, and inside it is exactly same. Un plus x dx. Exactly same what we have here. Okay, in that manner, solution will come as un plus 1 instead of un plus 1, and in bracket un plus m plus 2 minus un plus 2, or in well-behaved manner un plus 1 in bracket un m plus 2 minus 1 bracket close un in bracket um plus 1 minus 1 bracket close bracket close. Someone would say this is the exactly same result I had got when I did summation x equal to 1 to m uxn, that came as un and in bracket un plus m plus 2 minus un plus 2. This is same result. No. Outside you had un. Now outside it is un plus 1. N changed to n plus 1. That's it. Why it happened? Because our final integration was in two dimensions, in two variable case, x equal to 1 to m plus 1, y equal to 1 to n plus 1, dxy dy dx. This is what we did. Dxy dy, if I see dxy dy, if I see, then it is where x is constant. In that manner, it is matching to summation y equal to 1 to n g m comma y, where m is constant. Same thing. X is constant, m is constant. Wherever this result will go to that result, and we will just change x m y x. So result was un plus 1 into un plus m. So here result will be un plus 1 un n plus x. M changed to x. Now here un plus 1 is outside, it's a constant, I can keep outside in the integration. Un plus x dx x to 1 to m plus 1. This is exactly same what we got. Summation x equal to 1 to n p px comma n, where m is variable now. And result came as un outside and inside un plus m plus 2 minus un plus 2. Here outside is un plus 1, there outside was un. Just replace un outside with un plus 1 and inside un plus m plus 2 minus un plus 2. That can be decorated as un plus 1, that is there in the book, un plus 1 in bracket um plus 2 minus 1 bracket close plus un in bracket plus 1 minus 1 bracket close bracket close. This is the case when m is odd or even, does not matter. N is odd. We will talk about when n is even, bringing through. Otherwise, if someone is very enthusiastic, curious, then he can calculate 16 gxy. When x is even, then y is even odd. When x is odd, y is even odd. Now the final m and n, when m is odd, n is even and odd. When m is even, n 16 combination gx will come, and then he has to divide gxy as 6. Then there will be gap of 2 2. Right now we are taking to get gxy as x to x plus 1. He has to take x to x plus 2. Please watch our previous 6 to 7 videos, and there it is there. Okay, so please don't mind supporting us. +91 India country code 9483160610 telephone number. +91 India country code 9483160610 is the telephone number.